Okay, I'm going to go through a problem of pulling a crate on an angle to determine the acceleration. So a student attaches a rope 20 kilogram box, pulls with a force of 90 at an angle of 30. The coefficient of friction is 0.5. Find the acceleration. So here we go. Let's draw the free body diagram. We have F of n. It's on a horizontal surface. F of g is downward. My force applied is on an angle. This is 30 degrees from the horizontal. And I do have friction because they're talking about the coefficient of kinetic friction. This force applied is 90 newtons. So once again, we are going to break it up into horizontal and vertical forces. So my horizontal forces would be I have to break this up into components. This is my F of AX and my F of F. So I have the F net will be negative F of F plus F of AX. I'll have to figure that out with the triangle. We'll come back to that. My net vertical components are my F of N, F of G, and I also have an F of AY because that's part of that angled. So let's write F of N plus negative F of G since it's a downward force, plus also this upward force is contributing from the F of AY. So what we have to do, we're figuring out the acceleration, and we're given that the kinetic friction, mu, is 0.5. So what we need to do is go ahead and figure out some of our knowns. Now, vertically speaking, we know that this is equal to 0. So my F of G, because it is a mass of 20 kilograms, I need to take 20 kilograms times 9.8 newtons per kilogram. And we get an F of G of 9.8 times 20, negative 196. So this is negative 196 newtons. Now I need to go ahead and do some trigonometry here. So let's say 90 newtons here, 30 degrees, F of AX, F of AY. Cosine of 30 is going to give me my F of AX over 90. My sine of 30 is going to give me my F of AY over 90. So when we go ahead and compute those, we get a value of, we're going to say 78 newtons, and we're going to get a value of 45. So when we go back here, my F of AY is 45 equals 0 plus Fn. So when I solve for Fn equals 196 minus 45 newtons. So we get a value of 151 newtons for my F of N. I'm not done yet. When we come over here to horizontally, my F of F plus my FAX is going to be 78 newtons from this calculation here. And I know that my force of friction I can determine, because I have force of friction over F of N, is equal to that coefficient of friction. So let's plug in this F of N. This is my mu, and I can now go back and fit this in because now I can solve for that. So we're going to go and take F of F over 151 equals 0.5. 151 times 0.5 is going to give me a force of friction, kinetic friction that is, of 75.5 newtons, and that will be negative. So if I come up here to this problem, my F net horizontally, which is where the acceleration is coming from, since vertically speaking there's nothing happening, when I add those up, I get a value of 2.5 newtons for my F net. So let's go ahead and take this value and say F net equals mass times acceleration. That's going to be 2.5 newtons equals the mass of the object, which was 20 kilograms, times A. We're almost there, and we get a value of A equals 0.125 newtons, positive, rightward. And that's the problem.